Okay. Find the inverse of the one-to-one function. We talked about one-to-one function before, but let's concentrate on what's the inverse. I'm going to change that f of x to make it y instead of f of x. So if I have y is equal to 6x plus 9, can somebody tell me what would be the first step of finding the inverse of y? What would be the first step? There are 2 steps involved. Anybody remember that? Nobody remember the steps to find the inverse? Okay. The first step is to replace the position of x and y. Everywhere you see y, you change it with x. Everywhere you see x, you change that to y. Simple as that. And anybody remember the second step now? After that, what do? Solve for what? Anyone? Y. So the 2 steps involved. You exchange the position of x and y. The second step is solve for y. That's how you can find the inverse. How do you solve for y? You can tell me that, right? Who wants to tell me how to solve for y? Anybody with the mic?
Subtract the 9, divide everything by 6.
Very good. All right, so we subtract 9 and divide by 6. Very good. Divide both sides by 6. So it looks like y, in this case, becomes x minus 9 over 6. So this is really the inverse. I can write it y and then put this little symbol minus 1. That means it's the inverse. Yeah. So if I were going to call this f of x, like it was before, f of x equal to 6x plus 9, the inverse, if you put this little symbol negative 1 at the top of that, would be equal to x minus 9 over 6. So which one would be the right choice then? A, B, C, or D? X minus 9 over 6. Looks like it is B right there. Okay. Does this problem just ask you to pick which one is the inverse function? We didn't really dealt with this one-to-one function. Anybody know the characteristic of one-to-one function? If 2 functions are inverse of each other, then that would be what? What's the relationship between one-to-one and inverse? Anybody remember that or know that? No. Okay. So if 2 functions are inverse of each other, then that means those are our one-to-one function. There's one more thing I can mention here. We'll talk about this again later. If 2 functions are inverse of each other, then f of g of, let's see, so if I remember this one here. Anybody know what this symbol is? So circles should be smaller than that, but made a little big. Anybody know what function is this? So symbol. You need to know that for our next exam, actually. Somebody put multiplication. No? Anyone else? Okay. This is a composition. Composition of f respect to g, or composition of g respect to f. It actually is f of g of x. And this is g of f of x. If I take that symbol out, that's what it means. Okay. if I find f of g of x and g of f of x, and both of these turns out to be equal to x, has to be x exactly. Not only has to have to be same, but also have to be equal to x. Then we can conclude from that that g of x and f of x are inverse of each other. We're going to talk about this topic in more detail in separate problems. But since we're talking about the inverse function, I thought I'd just bring it up, just to at least to go look for the sessions that I've done talking about the composition functions and inverse function. But for this problem here, that's all you have to do, just find the inverse, which we did.